Hey guys, how you doing? It's Mr. Chavla. I'm here to go over the Part 4 key of the Common Core Algebra 2 exam from August 2016. That's just number 37, a nice six-pointer. And again, this is Mr. Chavla or Mr. C. All right, let's go ahead and get this done. And I would encourage you guys not to skip number 37, all right? A lot of people, they skip the last question or they skip the entire short answer response. That blows my mind. Don't do that, guys, all right? Give yourself every possible chance to succeed, okay? So let's read 37. Seth's parents gave him $5,000 to invest. So that means his money's going to grow for his 16th birthday. He's considering two investment options. So there's option A, which I'll use green. We'll pay 4.5% interest compounded annually. Option B, which I'll use blue for B for blue, will pay him 4.6% compounded quarterly. So it's compound interest, guys. Write a function for option A, which again I use green. So we'll write that in green. And for option B, which I use blue, B for blue, that calculates the value of each account after n years. So they're using n for the number of years. Now typically, guys, the compound interest formula would look something like this. I'm going to minimize me. The amount, let's say the amount saved, right, after t years is equal to the initial amount. So P is what's called the principal or initial amount invested or initial investment is equal to 1 plus R over n to the n times t power, where R is the interest rate, the annual interest rate, right? The yearly interest rate as a decimal. N is the number of compounds per year. How many times compound interest is compounded in a year? The number of compounds per year, the number of times compounded per year, same thing, right? T is the number of years, right? And S of t is just the final amount after t years. Now the problem is they want us to use n for years, and I didn't really like that, but here's how it's going to look like, guys. And the more you're familiar with the compound interest formula, you wouldn't have to go through all this. Just be careful to use n. What I'll do is I'm going to change the letters around so that we could use n for years. So here's how it's going to go. I'm going to use the letter, let's just say C. C for the number of compounds per year, right? C for compound. Or better yet, T for the number of times it's compounded per year, okay? So I'm going to reverse the T. So T will be the number of compounds per year, and N will be the number of years, okay? So T is the number of times it's compounded, N will be the number of years, simply because they said to do that, right? Then what the formula will change to is it'll be T over here, because that's the number of compounds per year, to the Tn. Same thing, okay? So let's use that to our advantage so we can now write the formula, okay? So for option A, which I was going to use green, for option A, we'll write A of n is equal to 5,000, the initial amount, times 1 plus our R value for A is 0.045 or 0.045. And if it's compounded annually, that's just once per year. So I'll say I use T for the number of compounds, so T equals 1. So it'll be 0.045 over 1 to the T again, which is 1, n, right? Now, this could be simplified further, and you didn't even have to use the compound interest formula. If you know if you know that when it's compounded annually, that's just saying it's just regular exponential growth formula. The formula will turn into this: A of n is equal to 5,000. 0.045 divided by 1 is just 0.045, which when you add to 1 becomes 1.045. And in the exponent, 1 times n is just n. So instead, we could just have used that formula, right? When it's just once a year. Okay, so let's write that again. And we didn't have to go through all those steps, but I want you guys to see how it works for those of you who needed it, okay? 5,000 times 1.045 to the n power. Now, if we look at the other function, R is equal to 0.046 Compounding quarterly, that means 4 times a year. So t equals 4, the number of times per year. So for option B, b of n is still, we still started with 5,000. If we use the formula, guys, and you have to memorize this, it's not given to you in the reference table. It's very similar to regular exponential growth. So plus r, we know r is 0.046. I could put it as put the 0 in front or not, but only the 0.046 is being divided by the 4, the number of compounds per year, all raised to the 4n power. All right? And we could simplify this formula farther as well, but I don't want to have to do that because all it said was to write the formula. We didn't have to simplify either one. So write a function for option A, which we did, and option B that calculates the value of each account after n years, which we got right here. Okay, so that I believe would have been 2 points already. Seth plans to use the money after he graduates from college in 6 years. Determine how much more money option B will earn compared to option A to the nearest cent. That's 2 decimal places. So ultimately what we want to do is how much more is option B, B of 6, compared to A of 6, right? So all we have to do is find out what B of 6 is, right? So we'll substitute 5,000, 1 plus 0.046 over 4 to the 4 times 6. And we don't have to show any work. We'll just find out what that is to the nearest cent. Okay, don't need another tab. I was wondering if I needed another one. So let's find out what that is. 5,000, 1 plus 0.046 over 4, all raised to the 4 times 6, which is 24, by the way. 6578.87. All right, option A will be easier to calculate. It'll be 5,000 times 1.045 to the 6th power, which will be about 6511.30. If I subtract, right, now I'm going to erase the markings I got here. If I subtract B of 6 minus A of 6, right, because I rounded both, let's do it first using the rounded values. 6578.87 minus 6511.30, and we get 6757. Let's make sure we get the same answer, because I don't like to round until the end. So 6578.869851 869851 8698851. All right, minus 6511.300624. Let me make sure I got that. 8698851 8698851 and 320624 320624 320624. It's still about 6757. So either way it rounds to 6757. So I'm just going to say $67.57 because they said to round to the nearest cent, right? So Seth plans to use the money after 6 years. Determine how much more option B will earn compared to option A to the nearest cent, $67.57. All right, that is our answer. Now we're going to move on to the final part of the question, all right? So that would have been 4 points right there. Algebraically, so that means we have to show work. Determine to the nearest tenth of a year, 1 decimal place, how long it'll take for option B to double Seth's investment. So option B, remember, was this one right here, the one with the 1 plus 0.046 over 4. So 5,000 times 1 plus 0.046 over 4, all raised to the 4n, is equal to, remember the initial investment was $5,000, which if I multiply by 2 is $10,000. All right, I'm going to divide both sides by 5,000 now. And I'm also going to find out what 1 plus 0.046 over 4 is. And that's 1.0115. So 1.0, was it 1 0 or 2 of them? Just 1. 1.0115. That's what it simplifies to right here, this part. To the 4n is equal to 10,000 divided by 5,000, which is 2. Now, I like to use the log with the same base. So the exponent is 4n is equal to log the base. See, I like to simplify it because otherwise I would have had to written the whole thing, 1 plus blah blah. So 1.0115 of the value 2. Then I divide both sides by 4. I don't like to round until the end. So I'm going to get n is equal to log of 1.0115 of the value 2 all divided by 4. And then I'm going to round to the nearest tenth of a year and I'll have my answer. So this one doesn't allow me to do log of selected bases, so I'm going to have to go in this calculator. All right. So functions, miscellaneous, log of the desired base. So it's log base 1.0115 of 2, and we wanted to divide it all by 4, and it's about 15.2 years if we round to the nearest tenth of a year, 15.2 years. All right, 15.15 will round up to 15.2. So I'll say here approximately 15 point, let's neaten that out, 15.2 years. All right, so algebraically determine to the nearest tenth, which we did. How long it'll take for option B to double his investment, and we did. Okay, so that was 6 points, guys. No, I don't think it was that bad. I'm just neaten this out here. There we go. Okay, so this was part one. If you know how to write compound interest formula, and we're just careful to use the correct letter, the n for years. We got the formula for A or B. That was one of the ways you could write each one. For that was for the first part, right? For part two, we found that option B, how much more it'll earn compared to option A after 6 years to the nearest cent. And then we calculated to the nearest tenth how long it would take for option B to double the initial investment. It was 15.2 years. All right, I thought that wasn't bad for a part for 37, all right? Okay, guys, so that was it for now. Best of luck. Thank you so much for coming by. I really hope, please don't skip any questions. Don't try to pull all-nighters. Get a good night's rest, okay? Do the best you can. Trust yourself. Get all the help you need, all right? And if you have any questions, comments, let me know. Anything you'd like me to go over again or go over differently, I'm more than happy to do so, okay? So best of luck from the bottom of my heart. And I'll see you next time, all right? When I'm going to start going over a different exam. And no stress, yeah? Try. I know it's not easy. And oh, and if you enjoyed the video, please hit like, subscribe. I would very much appreciate that. All right. Thank you so much. Bye for now.